Alright, let's take a look at these FRQs here. The first is going to be from 2011, question 1. If you can, go ahead and pause and find which one that is in your prep book. And problem reads as from 0 to 6, a particle is moving along the x-axis. The particle's position x of t is not explicitly given. The velocity of the particle is given by v of t equals all that stuff. The acceleration is given by a of t is equal to all that stuff. And x of 0 equals 2. I'm going to go and highlight that. I feel like that's going to be some really important information later on. So let's go ahead and just highlight that. Like that. I think that's important. Okay, so part A says, is the speed of the particle increasing or decreasing at time equals 5.5? Give a reason for your answer. Well, I think at this point we've done enough of this to know how to tell when the speed of a particle is increasing or decreasing. I'm going to go ahead and test v of 5.5 and then a of 5.5, and if the symbols are opposite, then the particle is slowing down. If the symbols are the same in either direction, the particle will be speeding up. So the first thing I'm going to do before I even begin this problem is punch everything into the calculator. I have already done that. So f2 is going to be the acceleration function. f1, the blue, is going to be the velocity function. Now, in case you guys don't remember how to do this, I'm going to go ahead and adjust the window also. The window in the problem states from 0 to 6. I'm going to do the same thing. From 0 to 6. I don't really care what the auto scaling will do. Alright, cool. So that's where we're at. Now, I'm not going to use this just yet. I'm going to go and hit this calculator that's running away from somebody. So I know that f1 is the velocity, so I'm going to go f1 of 5.5. And I get a number, okay? And I'm going to go f2 of 5.5, and I'm going to get another number. So it looks like they're both negative. So I'm going to go and transfer those onto my document here. And let's see. Let's go and answer this question here. Now that I have both my numbers, I'll go ahead and justify my answer. Since it says give a reason, I will say the particle is speeding up at time equals 5.5 because both velocity and acceleration are the same sign. And I will go ahead and edit the font. Okay, that's how you do part A. I'll be back with part B in a second. Alright, part B says, find the average velocity of the particle from the period 0 to 6. Okay, the average velocity. Now this question can be a little bit misleading because when you hear the words average velocity, you think that you might want to take a derivative or something like that. But remember, you're only given velocity and acceleration, and they actually tell you that the position function is not explicitly given. So how do we find average velocity if we are only given velocity? Well, remember guys, average velocity is just average rate of change. So if I could just integrate on a certain interval, a to b, of some v function, then I would get s, or in this case, sorry, keeping context of the problem, x of b minus x of a, right? And that would give me a change in my position, right? But remember, they want the average, and when I hear the word average, I think about that 1 over b minus a formula that we keep talking about. And that would simply just transfer over, and I'd end up with over b minus a, and that's average rate of change right there. That's my average velocity, right? My average change in position. So in the context of this problem, if I'm going from 0 to 6, it's going to be 1 over 6 minus 0, right? Because my integral is from 0 to 6. It would be 6 minus 0, or 1/6. In this case, v of t dt again. Yeah? And what that would give me is, it would give me, again, x of 6 minus x of 0 all divided by 6. So from here, I just got to punch that into the calculator. In fact, I don't even need to show this work right here according to the rubric. So I'll go ahead and hash that out, and then I'll be back in a flash. On second thought, I'm going to show you how I'm going to do it. Because we're going to do some work in the Inspire today, so I'll go ahead and show you. So what I'm going to do is I'm going to pull up the Inspire menu here, and I'm going to go ahead and minimize that if I can. Sweet. All right, so now I have to remember v of t is my f1 function in the Inspire. So I'm going to go ahead and hit Shift plus, and I'm going to integrate from 0 to 6. And I'm going to go ahead and back this up, and I'm going to go and multiply it by 1/6. 1/6 times that. And then I'm going to go ahead and hit f1 of x dx. And I'm going to hit Control Enter. That way I get the decimal version of it. Bam. 1.949 and all that stuff. So I end up getting 1.949380. Okay? Cool. Let's go ahead and maximize this again. Alright. Let's take a look at Part C. Alright, so Part C, let's go ahead and take a look at some total distance traveled here. How do we do total distance traveled? Well, what I'm going to do is I am going to have to use integration, right? I'm going to integrate, so this is Part C, I'm going to integrate from 0 to 6 because that's the interval that is being asked of me. And I'm going to go and just absolute value my velocity. And I believe I've already done the calculation, so let's see what we get. We end up getting this 12.57 number, so 12.57, excuse me, 12.5732886,511. Okay? Cool. So total distance traveled is relatively simple. It's Part D that really kind of gets us. So, for Part D, for between 0 and 6, the particle changes direction exactly once. Find the position of the particle at that time. Okay, so let's talk about how I'm going to do this. Well, in order for me to find out where the particle changes direction, what I have to do is I have to first find out, well, where does my velocity not just equal 0, but where does velocity cross the x-axis? Right? Because it's not just enough that the velocity would equal 0, because the velocity could equal 0 and keep heading in the same direction. So what I'm going to do is I'm going to head back to that trusty graph of ours. Trusty graph. I'm going to pay attention to the blue thing, because the blue is my velocity. Notice how right here we've got an x-axis crossing. So I've got to find out where that is. So analyze graph, I'm going to go to 0. I'm going to pick the blue graph. My lower bound is here, my upper bound is here. So it looks like my point of intersection is going to be this 5 point. So I can go ahead and say, nope, it's no longer a question of if we're crossing the x-axis. It's a question of when are we crossing the x-axis. So we can say that v of t, actually I'll go and do this in text. I'll say v of t crosses the x-axis at t equals 5.19552 and therefore changes direction. You can't see that, but that's okay, I'll fix it. Okay? So how does that help me? Well, if I know this to be true, ultimately, I have to just answer the question now. The question is, find the position of the particle at that time. So in other words, I want to know what is the position right here. How do I do that? Well, if I wanted to find out a particle's position, if I was only given velocity, I'd have to use integration. So the question is, what am I going to integrate? Well, I'm going to integrate, definitely, on a definite integral, pardon the alliteration there, it's going to be from 0 to this 5.19552. Now, why is it from 0? Some people may think that it's because that's obviously when the time of the experiment started. That's actually not true. The reason why I'm starting at 0 actually has more to do with this fact right here. It's that x of 0 equals 2. They give me the position at time equals 2. So what I'm going to do is, using the first fundamental theorem of calculus, I can say that if I integrated v of t dt sorry about that, I had to kind of clean that up. The pen was starting to lose its ink there. If I integrate from here from 0 to 5.19552, I would then get x of 5.19552 minus x of 0. So from here, it really is just kind of an Algebra 1 problem with a little bit of calculator work. So I know that I get x of 5.19552, because that's what I'm solving for. I'm solving for this thing, minus 2. Well, again, where did 2 come from? Well, 2 came from this fact right here, that x of 0 equals 2, right? So I can just make the substitution. From here, I just have to figure out what this is. Well, how do I do that? It's a good thing I have a calculator for that. So let's go ahead and just punch that into our cool calculator. I'm going to hit the calculator that's running away from somebody. I'm going to go Shift plus, because that's my hotkey for the integration, definite integral, 5.19552. Oops, not 2.1, 5.1. And so I'm going to integrate, not absolute value, but just straight up velocity. And I'm going to find out what that number is. That's 12.13 blah, blah, blah. So that's 12.134770. And that equals this. How do I solve for the x of 5.19 number? I add 2 to both sides. And just as soon as I run out of space, I end up with x of 5.19552 equaling, go to the right a little bit more, please. Thank you. 14.134770, blah, blah, blah. And that is the position at the time that the particle changed direction. Hopefully that is clear to you. I'll see you in the next FRQ.